question, there is a pulley. It has got IO as 10 kilogram meter square about this axis. This axis from here, this is a frictionless pulley over here. That is, at the axle there is no friction. A string passes over like this. Over here we have a 10 kg mass, and over here we have a 5 kg mass. Initially the whole system is at rest, and now this is released. Once this is released, so this will go down and this will strike the floor with some velocity. We are asked with what velocity this is going to strike the floor. Over here, one thing to be noted is, that is, when we say pulley is frictionless, it is only at the axle it is frictionless. But there is always a friction between this string and this pulley. There is a friction, so that there is no slippage between the string and this pulley surface. If you look over here, had it been frictionless, had there been no friction between this string and this pulley surface, then this would have simply moved like this and the pulley would not have rotated. But now the pulley will also rotate about this axis. What happens is, there are irregularities over there. If we draw this string, we draw, and we just bother about these irregularities only at our place of interest. So this is the string like this. So obviously it has, all the time it has irregularities. So these irregularities, they get struck with the surface. So when this string moves, this rotates along this pulley also. And rather over here, we say that is now because these irregularities, they are there, this is fixed like this, the tension over here and tension over here, they are going to be different. Rather, if this is going to be a larger tension over here and this is going to be T small, and the relationship is TL is equal to TS e raised to our mu beta. Where, if you look from this side, suppose this is a pulley or any rod, etc. that is there, and string goes from here to here, and over here suppose this is a larger tension, and over here this is small tension. The relation is TL is equal to TS e raised to mu beta, where mu is called coefficient of friction between this rope or string and the pulley surface, and beta is the called wrap angle, that is over here, that is where it is touching it. So this angle is beta. So TL is equal to TS e raised to mu beta. Otherwise also, if we understand in simple terms, had the T1 and T2 be same, then the torque of this force about this axis, that is T1 into R, would have been equal to T2 into R, that is clockwise movements is equal to anti-clockwise movements. Then there will not be any alpha of this pulley, but that is not happening. We know when this goes down, its velocity will be gradually increasing. When its velocity is gradually increasing, its angular velocity will also gradually increase. When the angular velocity is changing, we know that its alpha angular acceleration will be there. So it is going to have some alpha. If it is going to have some alpha, it means T1 is not equal to T2. So let's write the equations for number one, this block, they are going to be translational equations, and this is purely rotating. Then we will write for this a rotational equation, and then using the equation A is equal to R alpha, we will connect the linear equation, that is translational equation, with the rotational equation. Let's do it by the dynamics principle first. So for this, if we look at this, it is 100 Newton is force in the downward direction, taking G as 10 meter per second square. So equation for this is 100 minus T1 is equal to 10 into A. For this, T2 is in this direction, 50 Newton is in this direction, this will move up. So T2 is in this direction and 50 Newton is in this direction. Equation for this is, that is T2 minus 50 is equal to 5 into A. Axiom will remain same. Whatsoever the distance it goes down, the same distance it goes up. Whatsoever the velocity in this direction, the same velocity will be of 5 kg in this direction. Whatsoever is the acceleration of 10 kg block, the same axiom will be of 5 kg block. And for this, if we draw the force diagram for this, over here this is T1 and this side is T2. Torque, this is 1 meter, this is 1 meter. Clockwise movements, that is T1 into R minus T2 into R, that is net torque. As we have been using the formula net force is equal to mass into acceleration, similarly now we are using net torque is equal to I into alpha. As we have been doing in laws of motion, suppose 10 Newton is here, 4 Newton is here, we said net force is 10 minus 4, that is 6 Newton. Similarly, onto this body, if there is some torque which is acting in this direction and some torque is acting in this direction, that is, one is clockwise torque, the other is anti-clockwise torque. As over here we have subtracted the forces from the bigger movements, we'll subtract the smaller movements and we'll put it is equal to I alpha. So T1 into 1 minus T2 into 1, because this is rotating this way, so that's why T1 into R is bigger than T2 into R, is equal to I about O, that is given as 10 kilogram meter square, into alpha. Also, whatsoever is the acceleration of this point, the same is acceleration of this point, the same is acceleration of this point, the same is acceleration of this point. But this is also situated at the periphery of circle also. This at this instant, this is also moving in circle also. So we can very well use A is equal to R alpha. A is equal to R is given as 1 meter of this. So let's take it as radius as 1 meter for ease of calculations. So A is equal to 1 into alpha. So we have one equation over here, second equation over here. This is the third equation, and fourth equation, A is equal to 1 into alpha. Now let's see how many variables or unknowns they are there. T1, 1 unknown, A second unknown, T2 third unknown, alpha fourth unknown, and we have 4 equations. Now if we write the equations over here once again, so 100 minus T1 is equal to 10A, T2 minus 50 is equal to 5A, T1 minus T2 is equal to 10 into A. These 3 equations, if you directly add it, minus T1 plus T1 get cancelled, T2 and minus T2 get cancelled, 100 minus 50 is 50, is equal to 10 plus 5 plus 10, 25 into A comes out 2 meter per second square. And then we can use, that is, from here to here, V square minus U square is 2as. V is the velocity with which it is going to strike the floor. U is the velocity, initial velocity, that is 0. So V square minus 0 is equal to 2 into A is 2 into S is 2 meter. We get velocity as 2 root 2 meter per second. So this is how we have got it using the dynamic principles, where we have used the force, concept of force we have used the torque also, torque is equal to Y alpha, F is equal to ma, we have used it, and then we have connected these equations, that is rotational motion and this translation motion, we had connected by A is equal to R alpha, and we have got the answers. Now, is it possible that is we can solve the same question using the scalar methods, that is conservation of mechanical energy principle? Let's do it.